Topic is turbine. The first thing is about a turbine. It is a machine which converts the pressure and kinetic energy of water called hydraulic energy into mechanical energy. There are also called as water turbines. The mechanical energy of turbine is further converted into electrical energy by an electric generator which is directly coupled to the shaft of the hydraulic turbine. The electrical power generated is known as hydroelectric power. Hydraulic turbines are efficient. These have low wear and tear and ease of maintenance. The capital cost is high with a long gestation period due to the requirement of constructing the dam across the river and laying the long pipelines. This is the main classification of turbine. First thing is about impulse turbine and as reaction turbine. In impulse turbine it has Pelton wheel, Girard turbine, Turgot turbine, and from reaction turbine it is Francis turbine, Kaplan turbine and propeller turbine. This is the general layout of hydroelectric power plant. The water is stored in the dam and it has a head gate. From the head gate it is going to the water intake level. When the head tank is open, the water is flowed from the dam through a pipeline, and from that it will directly goes to the turbine. It has turbine as a turbine blades. Due to the water velocity, the turbine will be rotated. Due to the rotation of the turbine, the generator is rotating, and the generator is rotated based upon the speed which is created by the turbine. Depending upon the rotation of generator, the power will be created in the generator power, and the generator creating high power is stored in the transformer. From the transformer, the created electricity is transferred to the required usage and the remaining water is transferred to the water discharge. It is a two-dimensional diagram of what we are seeing in hydroelectric power plant. A dam which is constructed across a river to store water. It provides necessary potential energy to nozzles of a turbine. It acts as water reservoir. Top surface of water in the dam is called head race. The penstock is a large diameter pipe usually made of reinforced concrete or steel. It carries water under pressure from the water stored in a dam or reservoir to the turbines. General layout of a hydroelectric power plant. A water turbine which converts hydraulic energy into a mechanical energy. A water turbine can be set horizontal or vertical. The choice is governed by cost, type of turbine, building space and plant layout. A tail race is a discharge canal into which water is discharged from the turbine. Difference of head race and tail race is called crosshead. Pelton wheel or Pelton turbine. Pelton wheel is a tangential flow impulse turbine. In Pelton turbine, the water strikes the buckets along the tangent of the runner or the wheel. It is used for high heads more than 100 meter of water. These turbines have been built up to the head of 1600 meter. And the layout of a Pelton wheel turbine, already seen that. The wheel, first thing is about a penstock bend. It has a wheel and a nozzle setup. It is also called as a spear. The water comes from the dam which enters into the penstock bend, and the water level control which is used by a spear. The water is sprayed through the nozzle and the water is deflector. Water is deflecting use a deflector, and it will be directly gotten to the buckets or wells. It is also called as a runner. Due to the impingement of water on the surface, the runner will be rotated and the power will be generated based upon the shaft. It is covered by a casing for the non-removal of water inside the system. To stopping the runner, we used a system called braking jet or nozzle. The main components of a Pelton wheel are nozzle and a spear assembly, runner and buckets, casing, braking jet and deflector. Nozzle and spear assembly. The needle spear is provided in the nozzle to regulate the water flow through the nozzle. It provides the smooth flow of water with negligible loss of energy. A spear is a conical needle which can be moved in axial direction by operating the wheel either manually or automatically. Runner and buckets. The turbine rotor called runner is a circular disc fixed with buckets. It is provided with cylindrical bars and a key to the supporting shaft and small thrust bearings. The runner carries cup-shaped buckets more than 15 in number which are mounted at equidistance around its periphery. The buckets are either cast integrally with the circular disc or these are bolted individually to the runner. It helps in easy replacement of buckets when worn out. Braking jet. The turbine is brought to rest. The nozzle is completely closed by pushing forward the spear. The runner continues to rotate due to its inertia for the considerable period of time till it comes to rest. In order to bring the runner to stop in a shortest time, a small nozzle is provided which issues the water jet and falls on the back of the buckets. It acts as a hydraulic brake for reducing the speed of the runner. And the disc deflector. A deflector is provided which is hinged to the casing to deflect the jet of water away from striking the buckets in case of load on turbine suddenly reduces. It prevents the runner of turbine attaining unsafe speeds called runaway speeds. So this is the velocity triangle of a Pelton wheel turbine, which gives the value of U1, U2, V1, V2, VR1, VR2, VW1, VW2, and alpha and beta, theta and pi. So U1 and U2 which gives the peripheral velocity of the jet and inlet and outlet, V1 and V2 which gives the absolute velocity of jet and inlet and outlet, VR1, VR2 which gives the relative velocity of jet at inlet and outlet, VW1 and VW2 which give the wheel velocity of jet and inlet and outlet, alpha and beta which gives the guide blade angle at inlet and outlet, finally theta and pi which gives the vane angle at inlet and outlet. Thank you.